Hello coders, I welcome you all. In this video, we are going to discuss our next machine learning project, car purchase amount prediction using machine learning. In this project with different machine learning algorithms, this time we are going to discuss artificial neural network. At the end of this project, we will visualize this artificial neural network. So we are going to develop a machine learning model to predict the total dollar amount that customers are willing to pay while purchasing a car, given the following attributes that you can see over here: customer name, customer email, country, gender, age, annual salary, credit card debt, and net worth. So using these attributes, we are going to predict car purchase amount. So let's get started. So now first we are going to hide all the warnings. So for that, let me import warnings. Let me execute this cell and let me write warnings dot filter warnings. And here, let me write ignore. Let me execute this cell. So now, let me first import pandas as PD. Let me execute this cell. So as you can see over here, now our pandas library is successfully imported. So now let's load our dataset as pandas data frame. So let me write PD dot read underscore CSV because our dataset is available in .csv file format. So our dataset name is car underscore purchasing underscore data dot CSV. Let me assign it to one variable. Data is equal to this statement. Let me execute this cell. As you can see over here, now our dataset is successfully loaded as pandas data frame that you can see over here. So now to explain you this project, here I have mentioned some questions that you can see over here. So now let's solve them one by one. So now our question number 1. In this question, we have to display top 5 rows of the dataset. So for that, we have to use head method of pandas data frame. Let me execute this cell. As you can see over here, by default, this head method is displaying top 5 rows of the dataset that you can see over here. So this way we can display top 5 rows of the dataset using head method of pandas data frame. So now our next question. In this question, we have to check last 5 rows of the dataset. So for that, we have to use tail method of pandas data frame. Let me execute this cell. So by default, tail method is displaying last 5 rows of the dataset that you can see over here. And by that, we can able to know total how many rows are available in this dataset that you can see over here. So this way we can check last 5 rows of the dataset using tail method of pandas data frame. So now our next question. In this question, we have to find shape of our dataset, means number of rows and number of columns available in our dataset. So for that, we have to use shape attribute of pandas data frame. So please remember, shape is not a method. It is an attribute of pandas data frame. So now let me display it in proper format. So let me write print number of rows, comma, data dot shape. As you can see over here, here output is Python tuple. This is at index 0 and this is at index 1. So here index 0 and print number of columns, data dot shape 1. Let me execute this cell. So in our dataset, total we are having this many rows, and in our dataset we are having this many columns that you can see over here. So this way we can find shape of our dataset using shape attribute of pandas data frame, means number of rows and number of columns available in our dataset that you can see over here. So now our next question. So in this question, we have to get information about our dataset like total number of rows, total number of columns, data types of each column, and memory requirement that we can do with just one method, info method of pandas data frame. Let me execute this cell. As you can see over here, total we are having these many entries from index this to this. Total we are having this many columns, and as you can see over here, column names. So total we are having this many non-null values in this particular column, this many non-null values in this particular column. Likewise, as you can see over here, data type for each column that you can see over here. Here d types colon means in our dataset 4 columns with floating point data type, 2 columns with integer data type, 3 columns with object data type, and as you can see over here, memory usage for our dataset. So this way we can get information about our dataset like total number of rows, total number of columns, data types of each column, and memory requirement using info method of pandas data frame that you can see over here. So now our next question. In this question, we have to check null values in our dataset. So for that, let me write data which is pointing to our data frame, and let me use isNull method of pandas data frame. Let me execute this cell. As you can see over here, now it is displaying data frame with boolean values. So now let's perform sum of true values using this sum function. Let me execute this cell. As you can see over here, output is 0, 0 and 0, means we do not have any null value in our data set. So this way we can check null values in our data set that you can see over here. So now our next question. Here we have to get overall statistics about our data set. So for that we have to use describe method of pandas data frame. Let me execute this cell. As you can see over here. So please remember, by default this describe method is displaying statistics only for numerical columns that you can see over here. So let me take this age column. As you can see over here, count. So total 500 values in this age column, and average value in this age column, standard deviation in this age column, minimum value in this age column, and these are percentile values 25%, 50% and 75%. Means in age column 25% values are below 41. In this age column 50% values are below 46. In this age column 75% values are below 52, and maximum value in this age column is 70. Likewise, so this way we can get overall statistics about our data set using describe method of pandas data frame that you can see over here. So now our next question, visualization. So here we are going to perform just basic visualization using Seaborn's pair plot. By using this pair plot, we can get relation between each and every variables present in our data set. Let me show you this. So for that, let me import Seaborn as SNS. Let me execute this cell. As you can see over here, now our Seaborn library is successfully imported. So now let's use Seaborn's pair plot. So let me write SNS dot pair plot. So here let me pass data which is pointing to our data set. Let me execute this cell. As you can see over here, pair plot. By this pair plot, we can get relationship between each and every variables present in our data set that you can see over here. So we can use this pair plot to plot multiple pairwise bivariate distribution in our data set that you can see over here. So now let's look quick observation. So as you know, we are interested in car purchase amount, which is our target variable, this one. So as you can see over here, age and our target variable, car purchase amount. So as you can see over here, age increases, car purchase amount also increases, that you can see over here. Same is true for annual salary as well. Annual salary increases, car purchase amount also increases, that you can see over here. Now this column, credit card debt. Actually no clear relationships exist between credit card debt and our target variable car purchase amount, that you can see over here. So now as you can see over here, net worth. So from this plot we can see that net worth increases, car purchase amount also increases, that you can see over here. So this way we can get relation between each and every variables present in our data set using pair plot, that you can see over here. So now our next question. In this question we are going to store our independent variables in X and our target variable car purchase amount in Y. Also we are going to drop irrelevant features. So let me first display column names. So we are going to drop this customer name, customer email and country because they don't affect the purchase amount. So let me write X is equal to data dot drop, and we are going to drop these irrelevant features like customer name, customer email ID and country. And also as per our question, we are going to store our independent variables in X and our dependent variable in Y. Also we have to remove our dependent variable car purchase amount because we are going to store our dependent variable in Y. Let me execute this cell. As you can see over here, key error. Sorry for that. I forget to write X is equal to 1. Let me execute this cell. Now let me check. As you can see over here, now we have successfully stored our independent variables in X. So now let's store our dependent variable in Y, which is car purchase amount. Let me copy this and let me paste it over here. Let me execute this cell. As you can see over here. So this way we can store our independent variables in X and our response variable also called as a target variable in Y. Also we have removed irrelevant features like customer name, customer email, and country, because they don't affect the purchase amount, which is our target variable. So now our next question. So here we are going to perform feature scaling. Means we are going to perform normalization. So what is normalization? Normalization is a scaling technique in which values are shifted and rescaled so that they end up ranging between 0 and 1. So for that we are going to use min-max scaler. So for that, let me import from sklearn dot preprocessing. We have to import min-max scaler. Let me execute this cell. So as you can see over here, now our min-max scaler module is successfully imported. So now let's use this min-max scaler to perform normalization. So for that, let me create instance of this min-max scaler. I am using SC. You can use any. So now let me write sc.fit_transform. So here we are going to apply this min-max scaler on our independent variables available in X, and let me create one variable x_scaled is equal to this statement. Let me execute this cell. Let me check x_scaled. Let me execute this cell. As you can see over here, now our independent variables are scaled between 0 and 1, that you can see over here. So now we are going to use this min-max scaler on our target variable as well. So let me create another instance. sc1 is equal to min-max scaler. Let me execute this cell. So let me write sc1.fit_transform. And here I am going to pass our dependent variable y. And let me assign this to one variable y_scale is equal to this statement. Let me execute this cell. As you can see over here, it is showing this value error. Let me check. And it is telling we have to reshape our data using numpy's reshape method. So now let me create cell above and let me write y.values.reshape, and here let me pass -1 and 1, and let me assign into one variable y_reshape is equal to this statement. Let me execute this cell. Now let me copy this and let me paste it over here. Let me execute this cell. Let me check. As you can see over here, now our dependent variable is also scaled between 0 and 1, that you can see over here. So this way we can use min-max scaler to perform normalization, that you can see over here. So now our next question. In this question, we are going to split our data set into the training set and the testing set to evaluate the performance of our models. So for that, let me import from sklearn.model_selection. We have to import train_test_split module. Let me execute this cell. As you can see over here, now our train test split module is successfully imported. So let me write train_test_split. And here we have to pass our scaled independent variables, which are available inside x_scaled, and our scaled dependent variable available inside y_scaled. And let me set test size to 0.20, means we are going to keep aside 20% data for testing purpose. And let me set random_state to 42, and let me assign this to x_train, x_test, y_train, and y_test is equal to this statement. Let me execute this cell. As you can see over here, so here you can see two sets, one for training and one for testing. So please remember, we are going to train our model on xtrain and ytrain, and we will perform prediction using xtest, our unseen samples, and we will compare predicted results by our models with ytest. So this way we can split our data set into the training set and the testing set using train test split module, that you can see over here. So now our next question. Here we are going to import different models. So let me write data.head. So as you can see over here, this is our response, also called as a target variable. So as you can see here, our target variable is having continuous values, right? So this is regression problem. So now let's import different regression models. So let me import from sklearn.linear_model. Let me import linear regression. From sklearn.svm, let me import SVR. from sklearn dot ensemble, let me import random forest regressor. From sklearn dot ensemble, let me import gradient boosting regressor. From xgboost, let me import xgboost regressor. Let me execute this cell. As you can see over here, now our models are successfully imported. So this way we can import different models that you can see over here. So now our next question. So now here we are going to perform model training. So let me create instance of linear regression LR. So LR dot fit, and here we have to pass our training set xtrain and ytrain. Let me create instance of SVR support vector regressor, and let me write svm dot fit, and here we have to pass our training set xtrain and ytrain. Let me create instance of random forest regressor RF. Let me write RF dot fit, and here we have to pass xtrain and ytrain, our training set. And let me create instance of gradient boosting regressor. Let me write GBR is equal to this statement, and let me write GBR dot fit xtrain and ytrain. And let me create instance of gradient boosting regressor XG is equal to this statement, and XG dot fit on xtrain and ytrain. Let me execute this cell. As you can see over here, now our models are successfully trained on our training set that you can see over here. So this way we can perform model training using fit method that you can see over here. So now our next question, ANN. As you can see here, we are going to create this type of artificial neural network. So please remember, artificial neural network contains different layers that you can see over here: input layer, output layer, and there can be multiple hidden layers that you can see over here. So input layer, where we will give our features. Here, output layer, where model gives us predicted values. And here you can see in between there can be multiple hidden layers. So we are going to create exactly this type of artificial neural network. So here input layer has 5 neurons because we have used 5 features: gender, age, annual salary, credit card debt, and net worth. And we are going to create 2 hidden layers, each with 25 neurons. And our neural network has only 1 neuron in the output layer because we are expecting one output from our neural network: car purchase amount. So we are going to create exactly this type of artificial neural network. So let's get started. So now first, building the artificial neural network, ANN. So for that, let me import TensorFlow.keras. Let me execute this cell. So as you can see over here, we have successfully imported Keras, which is an API-like function which sits on the top of TensorFlow. Keras uses TensorFlow as the backend. So now let me import from Keras.models. Let me import sequential. So please remember, this sequential specifies to Keras that we are creating model sequentially. The output of each layer we add in the input to the next layer we specify. So we are going to build our artificial neural network from left hand side, from input going through different hidden layers until we reach the output. So now let me import from Keras.layers. Let me import dense. So please remember, this dense is used to specify the fully connected layers. So output of the layers fully connected to the input of next layers. Let me execute this cell once again. As you can see over here, now our modules are successfully imported. So now let's initialize the artificial neural network. So for that, we have to use sequential API. So let me create one instance of this sequential class, ANN. Let me execute this cell. As you can see over here. So now our next question. Here we are going to add first input layer and first hidden layer to our artificial neural network. So for that, let me write ANN instance that we have created, which is instance for this sequential class dot add, and here we have to pass dense. So this dense class create fully connected object. So in the first argument, we have to specify number of neurons in the first hidden layer. So let me pass 25. So we are going to add 25 neurons in our first hidden layer. So here you might be wondering how to select number of neurons in the hidden layer, right? So please remember, there is no such rule. It is just based on experiments. So now next, In the next argument, we have to provide input dimension. In our case, 5 inputs, right? So let me write input underscore dim is equal to 5, and our activation function is relu. Let me execute this cell. So as you can see over here, we have successfully added input layer and our first hidden layer to our artificial neural network. So now let's add second hidden layer. So again, let me write ann dot add, and here dense, because we are going to create fully connected artificial neural network. So again, we are going to use 25 neurons in the second hidden layer, and again our activation function is relu. Let me execute this cell. As you can see over here, now we have successfully added our second hidden layer. So now let's add output layer to our artificial neural network. So again, let me write ann dot add dense, because we are going to create fully connected layer. Here I am passing one neuron in the output layer, and activation function is linear. So as you can see, only one neuron in the output layer, because we are going to predict one value, car purchase amount, right? And in the output layer, we have used activation function linear, and this activation function is good for regression analysis. So that's why here we have used activation function linear in the output layer. So congratulations, we have successfully created our fully connected artificial neural network that you can see over here. Exactly like this: input layer, output layer, and two hidden layers that you can see over here. 5 neurons in the input layer that you can see over here, and 25 neurons in the first and the second hidden layer that you can see over here. 25 neurons in the first hidden layer and 25 neurons in the second hidden layer with activation function relu that you can see over here. And our output layer contains only one neuron that you can see over here with activation function linear, because we are going to predict only one value, right? Car purchase amount that you can see over here. So this way we can create simple artificial neural network that you can see over here. So now our next question. Here we are going to train our artificial neural network. Before that, let's check summary for our artificial neural network that we have just created. So for that, we have to write ann.summary. Let me execute this cell. As you can see over here, this table is showing layer type, output shape, and parameters. In our artificial neural network, total we are having this many parameters and this many trainable parameters that you can see over here. So why here is 150? First of all, please remember, in neural network, we are training weights with biases. I am repeating, in neural network, we are training weights with biases. So as you can see over here, in our created neural network, 5 neurons of our input layer fully connected with 25 neurons of our first hidden layer. As you can see over here, 10 neurons plus 15. So total 25 neurons in our first hidden layer. And as I said, in neural network, we are training weights with biases. And please remember, biases are associated with each and every neurons. So here we are having 5 into 25 weights, because 5 neurons of input layer fully connected with 25 neurons of first hidden layer. So 5 into 25 weights plus 25 biases. So this 25 biases associated with each and every neurons of first hidden layer here. So total trainable parameters are 150 here. So 5 into 25, 125 weights plus 25 biases. So here total trainable parameters are 150. So that's why here 150. So why here is 650? So as you can see over here, 25 neurons of first hidden layer fully connected with 25 neurons of second hidden layer. So total weights are 25 into 25. And as I said, biases are associated with each and every neurons. So here we have to add 25, because 25 biases are associated with each and every neurons of our second hidden layer. So here 25 into 25 weights plus 25 biases is equal to 650. So that's why here 650. Now why here is 26? So as you can see over here, 25 neurons of second hidden layer fully connected with one neuron of output layer. So total weights are 25 into 1 plus here 1 bias which is associated with output layer. So total is 26 trainable parameters. So that's why here is 26. So total trainable parameters is equal to 150 plus 650 plus 26. So total sum is 826. So that's why here total parameters are 826 and trainable parameters are also 826 that you can see over here. So now let's train our artificial neural network. So first let's compile our ANN. So for that we have to write ANN dot compile and here we have to pass optimizer and we are going to use Adam optimizer and also we have to find loss using mean squared error. So as you can see over here we have used Adam optimizer and shortly we will train our model on training data and find what loss can be. So we want to minimize this mean squared error, which is our objective means our loss function. So let me execute this cell. So now let's train our model on our training set. So for that let me write ANN dot fit and here we have to pass our training set X train and Y train and let me set number of epochs to 100 and let me set batch size to 50 and let me set verbose to 1 and let me write validation underscore split is equal to 0.2. So please remember here we have passed our training set and epoch means number of iteration and this batch size that we have set to 50. So please remember usually dataset is very big. We can't fit complete dataset once. So we can use this batch size parameter. This divides our data into batches. Each of size equal to batch size. In our case 50. So now only this number of samples will be loaded into memory and processed. And here we have set verbose to 1. It represents how many information want to show during training. And here we have set validation underscore split to 20% just to remove overfitting and to make model generalize. So here we are taking 20% data which is subset further from the training set. Let me execute this cell. As you can see over here. Now our ANN training is started that you can see over here. And at the end it will minimize the loss that you can see over here. So this way we can train our artificial neural network that you can see over here. So now our next question. Here we are going to perform prediction using unseen samples available inside X underscore test. So for that let me write LR instance that we have created for linear regression dot predict. Here I am going to pass our unseen samples available inside X underscore test. Let me create one variable Y underscore pred1 is equal to this statement. So Y underscore pred1 contains predicted values by this model. Let me copy this statement and let me paste it over here 5 times. Total 6 because we have used 6 models. So let me change it to 2, 3, 4, 5 and 6. So instance of support vector regressor SVM, instance of random forest regressor that we have created as RF, instance of gradient boosting regressor GBR, instance of XGBoost regressor XG and instance of artificial neural network ANN. Let me execute this cell. As you can see over here, now predictions are available in these variables Y underscore pred1 to Y underscore pred6. So this way we can perform prediction on unseen samples available inside X underscore test. So now our next question. Here we are going to evaluate our models using R squared score. So for that let me import from sklearn, let me import matrix. Let me execute this cell. As you can see over here, now our matrix module is successfully imported. So let me write matrix dot R2 underscore score and let me press shift tab over here. So here we have to pass actual values and predicted values. So actual values are available in Y underscore test and predicted values by our linear regression available inside Y underscore pred1. So let me pass y underscore pred 1, and let me store this r squared score into one variable. Score 1 is equal to this statement. Let me copy this statement and let me paste it over here 5 times. Let me change it to 2, 3, 4, 5 and 6. Let me change it to y underscore pred 2, 3, 4, 5 and 6. Let me execute this cell. Let me print this score values. Let me execute this cell. So now let's visualize this score. So for that I am going to create pandas data frame. So let me write pd dot data frame that I am going to create using Python dictionary. Let me write models as a key, and here let me write LR for linear regression, SVR for support vector regressor, random forest regressor, gradient boosting regressor, XGBoost regressor, ANN for artificial neural network. And let me create another key, R squared score. And here in the Python list, let me pass score 1, score 2, score 3, score 4, score 5 and score 6. Let me execute this cell. As you can see over here, let me store this pandas data frame into one variable. Final underscore data is equal to this statement. Let me execute this cell. Now let me print final underscore data. Let me execute this cell. As you can see over here, now our pandas data frame is created. So now let's visualize this. So for that, let me import cbon as SNS. Let me execute this cell and let me use SNS dot bar plot. On x-axis, let me pass final underscore data and this column models. Let me copy this column name and let me paste it over here. On y-axis, let me pass final underscore data and r squared score column. Let me copy and let me paste it over here. Let me execute this cell. As you can see over here. So from this bar plot, we can see that linear regression and artificial neural network are performing better than any other models that you can see over here. So we can use linear regression or artificial neural network for our production. But this time we are going to use artificial neural network in our production. So now our next question. Here we are going to save our best model, artificial neural network. So again and again training is not required. And we can perform prediction using this saved model. So as you can see over here, I have created neural network once again. Exactly same way as we have created earlier. Just I have replaced x underscore train with x underscore scaled and y underscore train with y underscore scaled. Please remember, we have used the train test split just to evaluate the performance of our model. For production, we have to train our model on entire dataset. So that's why here I have replaced x underscore train with x underscore scaled and y underscore train with y underscore scaled. So here I have trained our artificial neural network on entire dataset that you can see over here. And also I have removed validation underscore split parameter. Let me execute this cell once again. As you can see over here, now our best model artificial neural network is successfully trained on our entire dataset that you can see over here. So now let's save our best model artificial neural network. So for that I am going to use joblib library. So let me import joblib. Let me execute this cell. As you can see over here, now joblib library is successfully imported. And let me write joblib.dump to save our model. Here we have to pass instance of our best model artificial neural network. And here you can pass any name. Let me write car underscore model. You can write any. Let me execute this cell. As you can see over here, now our model is successfully saved. In future, you can perform prediction using this saved model. Let me show you this. So for that, we have to write joblib.load. And here we have to pass this name. Let me copy this name and let me paste it over here. Let me store this into one variable model is equal to this statement. Let me execute this cell. As you can see over here, now our saved model is successfully loaded. So now we can perform prediction using this saved model. Let me show you this. So here, let me first import numpy as np. Let me execute this cell. As you can see over here, our numpy library is successfully imported. So let me display first row of our dataset using head method. As you can see over here. So now let me create numpy array for prediction. And I am going to pass these values. For gender, let me pass 0, age 42. Let me copy this annual salary and let me paste it over here. Let me copy this credit card debt value and let me paste it over here. For teaching learning purpose, I am using these values, but you can use any. So here we have to create 2D NumPy array. And now let's perform normalization using sc.transform because we have to normalize these values using min-max scalar. So please remember, here I have used first instance of min-max scalar that we have created for independent variables. And let me assign it to one variable. X underscore test1 is equal to this statement. Let me execute this cell. Let me check. As you can see over here, now our values are normalized between 0 and 1. Now let's perform prediction using our based model, artificial neural network. Let me pass X underscore test1, this one, and let me assign it to one variable Fred is equal to this statement. Let me execute this cell. Now let me check. As you can see over here, we are getting normalized value. So now we have to perform inverse transform. So now I am going to use second instance of min-max scalar that we have created for dependent variable sc1 dot inverse transform. Let me execute this cell. As you can see over here. So this is predicted value by our model artificial neural network, and this is actual value available in our dataset that you can see over here, which is very near, and this value is predicted by our based model that you can see over here. So this way we can perform prediction using our saved model that you can see over here. So now our next question, GUI. So here I have created GUI exactly same way as we have created for our previous projects. I am sure you must be knowing this because we have created it from scratch. So let me execute this cell and let me execute this cell as well. So now let's perform prediction using this GUI. Let me pass these values. Let me press this predict button. As you can see over here, same answer. So this way we can perform prediction using our created GUI. So now our next question. Here we are going to visualize our artificial neural network. So for that you have to install these two libraries. I have already installed it. So for that let me write from ann underscore visualizer dot visualize. We have to import ann underscore vis. Let me execute this cell. As you can see over here, now this module is successfully imported. So now let me write ann underscore vis. And here we have to pass our instance ann. And here you have to write title. You can write any. Let me write ann. Let me execute this cell. As you can see over here, we have created this artificial neural network that you can see over here. Input layer, two hidden layers, and one output layer. Input layer with 5 neurons, two hidden layers with 25 neurons, and one neuron in the output layer. So this way we can visualize artificial neural network. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.